this for, we'll study our topic that is work per energy. In that, I'll be going through the recall also. First, we'll revise the things. Okay? Okay, tell me, you want the revision or you want directly start from the variable force? What do you say? Do you want the revision or do you want to directly start, like I must start directly from the variable force? What do you say, students? What do you say? Anybody? What do you say? I must directly start or start from the recall? Nobody's replying. What does it see? What does it mean if you're not replying? Reply ही करोगे तो how I'll get to know? Okay, let me put this in the spotlight. Spotlight for everyone. Later. Okay. Let us start. It's coming so dark on this. Light is not, lightning problem. Okay. Let me on that light. Okay, students, now I'm not going to waste time. We have not wasted, by the way. We have used our time to check all the things. So I'm going to start it. Revision recall. Okay, so you are saying, sir, see, JNB Uttarakhand, Canada students are saying revision. Sweetie says recall. Suman says recall. Parth says recall. Bellary JNB students recall. Sweetie again recall. Okay, so you want recall. So we'll start with the recall. Recall. Okay, so focus here. I am from Rajasthan. Okay, I done my master's in physics. I'm from Rajasthan. I done master's in physics. I'm from NIT Surathkal. Okay. I studied in NIT Surathkal, National Institute of Technology, Surathkal, Mangaluru. Okay. Got it? Finish? Okay. So, but these things are not so, it's fine. It motivates you. But the main thing is this, you must understand the class. Okay. Respective of, okay. So see, this is what? This is something I also not able to get it. What is this thing? Okay, so this is something like tong tong, alarm bell. Now I hope you're able to hear the sound also. So this picture is giving me what? It means we have to start the class. Okay, and it also gives you effect of how the sound is what? Energy. So from there, from this you can get what? This will produce what? A sound. Okay, and sound is what? Energy. So you know about the energy. Now let us start the chapter WP, work per energy. So this is what you can see. This ball, ping pong green color ball is moving. I'm also moving my cursor, tracing the. It's like roller coaster. It's going like this. It's coming. Okay, let us see again. It is what? Roller coaster is on the top. Roller coaster. Circle. Up, down. So what is this happening? We'll understand. See, when this green ball is moving up, there is the energy changes. Potential energy, ground potential energy changes to kinetic. When it moves up, the potential energy is stored in it. When it moves down, kinetic energy, that stored energy is converted. So we'll study all these energy fundas today. This energy, what's happening inside fundas. Oh, I must not write this fundas. I must write something else. Energy. We'll study all these energy changes in this today. Okay, energy changes. We'll understand today. Okay, got it? Okay. Some are saying work done. We'll also study about the work done. So WP chapter is what basically, if you see, WP is what? It's WPE means work. You will understand what you will understand in the physics language. Work done defined is what? Okay. Then you will understand that what is power. Then you will understand what is energy. So work, power, energy are the three things here you'll be able to understand. closing the video. Okay, students. Scalar product and work. What is this? Scalar product and work. See, so for before studying the scalar product and work, let me tell you, we will cover in this recall session first scalar product, work, then we'll study conservative and non-conservative forces. Okay, as per your demand. See, you only told me to recall. Otherwise, I will start directly from variable forces. See, let us understand what is this thing known as multiplication of vector. What is this thing known as multiplication of vector? Suppose, but before studying this, you must understand how the vector is multiplied. Okay, vector can be multiplied with a scalar quantity like numbers, lambdas, 1, 2, 3, 4, 5, 6, up to etc. Infinite doesn't exist. Vector can be also multiplied with a vector quantity. Vector quantity matlab, suppose a vector named as a equals to 2 I cap. If it's multiplied scalarly, scalar product, if it's multiplied scalarly by 3 I cap, or this is multiplied by C vector, which is 2J cap. So upon multiplication of A, that is the dot product or scalar product with B, what is the answer? And upon multiplication of A with C, what is the answer? I hope this all things you know already. So we say like this. With vector quantity, also the two kind of products are defined. That is scalar or dot product, that is A vector dot B vector, which you already know, students. It is equals to what? A ka magnitude, B ka magnitude, cos of the angle between them. So if the vectors are like this is A vector, B vector, theta is the angle between them. So I will define A dot B is this. Dekho. A vector ka, this is A magnitude, B vector ka, this is B magnitude. Okay. Now, so, I mean, again, they are explaining the things here. So it is denoted by dot cross product. So A vector cross B is defined as, everybody knows this thing. Can you tell what is the answer? A cross B ko kya kehte hain? What do we say? Hurry up, students. Hurry up. Hurry up. Tell students. Anyone of you? Okay, A cross B is defined as A ka magnitude, B ka magnitude, sine theta, n cap. Okay, so there is a difference between dot product and sine product. You already now you'll see it. Scalar product kya hota hai? Just see the animation. Focus on the animation. A dot B is this. Okay. A dot B is this, where it is A B cos theta. It's a scalar quantity. Geometrical. So it is like this. A dot B is A B cos theta. Okay, what does it mean? Now there is some other explanation. Okay, you want to see the last slide? Okay, see this. Last slide. Last slide. Okay. Dekh liya? Any doubt? You want me to be slow? So, धीरे धीरे बोलो. You want me to be slow? I'll be slow. No issue. Okay. Before this, so you are writing the notes now. Okay, maybe you are new. Okay. So before this is this slide. See, dot product का मतलब होता है, dot product means is dot producting these two things. Okay, I'll see few students. See, listen, all of you. Few students here are new, so I will not speed the lecture now. I will go through the lecture very slowly, like a beginner. Okay. So see, this is what A vector. Okay. This is what B vector. A dot B is defined as by this symbols, and it is equals to this. That is, if you dot product two vectors, which is having an angle theta between them. So it gives us this quantity, which itself is not a vector. See, this vector quantity, when dot producted with this symbol, it gives you ska magnitude, which is a scalar quantity. Ska magnitude multiplied by this scalar quantity. Scalar multiplied scalar is scalar. Cos theta multiplies. Cos theta value fluctuates from +1 to -1. This is algebraic. Scalar. Scalar into scalar into scalar will give you a scalar quantity. So this is in turn implies it's a scalar quantity. Okay? Dot product. Next. Geometrical meaning. So see, we have seen the mathematical meaning. Now geometrical meaning plus physical significance kind of. It is like this. See, suppose we are having, this is what a B vector. Okay? This is what this complete is A vector, by the way. I'm showing you in this slide. So suppose we are having a vector and this B vector. Okay. This is cos theta. This B vector is having a very good length, very big length. This B vector is having very big length. Okay. Hold on. Oh, you can do this also. See, suppose if I write like this, A dot B, I will write A dot B as A magnitude, B magnitude, cos of theta. But now, if I do some shifting here, do some smartness here, that is, I shift cos theta in between. So it will be A cos theta into B. So I can read this A dot B dot product like this. I can read this A dot B dot product like this. That is, when its projection A cos theta, I mean with magnitude, its projection is multiplied by this B vector's magnitude, I'll get A dot B product. Is it fine? समझ में आ गया? Did you understood this thing? Very good. Similarly, okay, you can unmute yourself. No issue. If it's very emergency, I mean very important, you want to say something, you can unmute. Okay. So similarly, students, Blairi students. Okay. Similarly, if you see this upper example, from this we can say B cos theta multiplied by A. This will give us A. Okay. No, not. See, if you're eating something and keeping yourself unmute, that is not a thing. Okay. Parth, please mute yourself. And any other person? No, no one. Fine. Not unnecessary. Okay. This is fine. So this is for both the vectors defined. I mean, you can either take the projection of B on A and write like this, multiply the magnitudes, you will get A dot B. Either you can take the projection of A on B and multiply with the magnitudes, A cos theta with B. You will get A dot B again there. No problem, Parth, no problem. Okay. Concept test. So students, did you understood? And now are you ready for the concept test? Students, are you ready for the concept test? Concept test is on this only, but we have studied A dot B. Both the things, geometrical and mathematical equation. A, B, which is what? A means this, B means this. Okay? Cos theta. Got it? This is what? This is what? This is what? This is scalar quantity. Scalar matlab magnitude. Scalar matlab magnitude. Are you ready for the concept test? Okay? So I'm launching this here. See this concept test. Tell me the answer. Tell me your answer. Magnitude. Okay. Magnitude of the vectors are given. A, two vectors are there. Its magnitude is given as 4 units and 6 units. Matlab A vectors, A is given as 4 and B vectors, B is given as 6. Okay? An angle between A and B is given as 60 degree. You have to find A dot B. You have to find A dot B. What answer you'll give? Okay, fastest answer is given by the champion of the class. Beleri have given the answer. Sweetie have given the answer. Edwin given. Uttarakhanda given the answer. Very good. Yes. Check your solutions now. I'm writing here. I'm writing here. Check your solutions. White pen, white, black and white combination. A vector, magnitude 4. B vector, magnitude 6. Okay. Okay. A dot B is what here? So we'll say A dot B will be what? Simple. A ka magnitude multiplied by B ka magnitude, take multiplied by cos of the angle between them, that is 60 degree. So this will give you 4 into 6. Cos 60 is how much? Sin 60 is root 3 by 2. Cos 60 is half. So this will give you the answer is 3. This is 12 units, the final answer. So all those students who got 12 units, what do we say there? Clapping. Okay. I mean, it's good. So yeah, at least you understood the concept. If you're able to solve this question yourself, you understood the concept. Okay. Now let us see the printed version of this. Printed solution. Printed solution is this. Dun, 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 dun. Okay. 12 is the answer. Be happy if you got this answer. Okay. Yes. No. Yes. No. What? Okay. So next challenge test. Are you ready for the next concept test? Are you ready for the next concept trip, everybody? Students, are you ready here? All of you? Trishna have also joined. Very good. So solve this question now. Okay. Very good. Solve this question now. This is I dot I, J dot A. Okay, I'm giving you some hints here. I is the direction of, it's not hint, you already know. I is the direction of X cap or X cap. J cap direction or Y cap, or Z direction Z cap or K cap. Okay, given answer. Okay, students have given already the answer. Path given, Baleri students given, Patel, Path have given again, admin. I'm giving you time, 30 seconds. Answer. 30 seconds answer. Okay. 101000011010. Okay. So I am writing here. I'm writing here. See, I'll give you very good solution. See here now. Check your solutions with here on the slide. Okay. So they're saying find I dot I, J dot J, K dot K, and I dot J, J dot K, and K dot J. Okay. First of all, let us erase all these things. So let us make a Cartesian coordinate system. This is not Cartesian coordinates. So a line here, it is I cap. I cap matlab along x-axis, positive. This is Y cap. J cap. J cap matlab along positive y-axis. This is Z cap. Z cap matlab along positive z-axis. ठीक है? This center point is origin. Origin मतलब 0, 0, 0. इसका क्या मतलब है? इसका मतलब है x0, y0, z0. Coordinates of center point, origin point. Finish. Now if we see here, students, angle between I, J cap is how much? Angle between I and J cap is how much? It's 90 degree. Angle between I and Z cap or K cap is how much? K cap, it's K cap, right? K cap. It's how much? 90 degree. Angle between J and K cap is how much? It's again 90 degree. Okay, finish. Simple. So now individually, if we are doing the dot products. I cap itself is what? Magnitude 1. It's a unit vector. J cap magnitude itself is what? Okay, JNV Chitradurga students, your answer is right. Okay, very good, excellent. All of you excellent, very good. J cap, those who are not able to solve this, what's the solution? J cap is what? Unit vector. Magnitude is what? 1. K cap is what? Unit vector. Magnitude is what? 1. All are having same magnitudes. Now, first they're asking do this. इसका मतलब first magnitude, second magnitude multiplied by cos of the angle. So angle is what? I and I are parallel, 0 degree. This is 1. J dot J similarly 1. K dot K similarly 1. ठीक है? Finish. And rest I will do 1. Okay, let us do K dot I. K dot I is how much? K का magnitude 1, I का magnitude 1. Cos of the angle between them. Angle between K, that is Z axis, and I is what? It's 90 degree. So cos 90 is what? 0. 0 into something, it will, 0 is like black hole. If things are going inside it, all things will go inside. Okay, I mean, never turn back condition. So it's 0. 0. Okay. From this we'll say, we can say like this, इसका answer is 1, इसका answer is 1, इसका answer is 1, इसका answer is 0, this answer is 0, this answer is 0. Okay, and this is a solution. Now let us move towards the printed version. So printed version solution, let us check again. Yes, it's fine, it's 0, 0. Okay. So see, in the component format, if I do the scalar product, now focus here, it will be how? See this, A dot B, A vector dot B vector. I will give you, remember always, I symmetrics will give you 1. Similarly, J, okay. So like this, if I do, this will give you 1. It means this will multiply. This and J will 0. This and I will 0. J and J will 1. So again, AY, BY. We'll get this answer. Okay. See this. What's the answer we're getting? We're getting the answer as this. Mark this in your notes. It's important. 5-star rating. Okay, it's important. According to vector purpose. Okay. Let us solve. Okay, I'm giving this question as a homework. Note it down. On the PDF, it will be available. Okay. On the PDF, it is available. This is a homework for you. You will get it on the PDF. Okay. See the notes. This is also on the homework. This is a solution actually. Leave this. Properties of scalar product. Okay. So I'm skipping this because you have already seen. Is it fine, students? Let us skip this thing, properties, because we have recalled the main part. Oh, that is a homework. It will be available on the PDF, Bellary students. You can see the PDF. Okay. Bellary students, is it fine? That is the homework last slide. PDF देखोगे, then you have to solve the question and come in the next class. ठीक है? Not replying. See properties. Okay, write Bellary students the slide, write it. Okay, now let us start the work. The rest of the things are properties, no need to revise because sir have already done that part. Okay. Now we have seen scalar product mathematics, which is required for this understanding of work. We have studied. Okay. Why we said this scalar product? Do you know this thing? Because you will understand that mathematically, to understand the work, which is force vector dot product with displacement vector. For this, you need to understand the scalar dot product mathematics that we have studied now, completed. Okay. Now let's understand this work condition. What is this work is? Work kya hai? In physics, what is it? So you can see here, you are solving your homework problem in your mind. Is this a work? I'm asking from you. What do you say? Students, if you're solving a homework problem in your mind, what do you say? Is it everyone must reply? If you're not replying, I will not go forward. If you're solving your homework problem, is it a work or what? Why? Reason. Tell me reason. Tell me the reason also. What do you think? What is the reason for this? Answer in the chat box. See here. This is not a work. In usual language, we say like this, that this is a work, but this is not a work. Okay. According to the physics, what the physics gives a definition of the work, no, that we have to keep in mind. So remove all your earlier concepts back from your head. Okay. Remove it. Forget that. We people see work is like this. If I am writing something, I'm doing work. Okay. If you're talking to something, you'll say, okay, he's doing some work, he's talking to something. No, it's not good. I mean, it's not the physics, according to physics. According to physics, work, what is work? So according to physics, we'll say like this. Yes, very good. So all the Jainvis, I will not say the name individually now. Okay. So you are saying right answers. Okay. What about this? A person carries buckets of water along a horizontal path while walking with a constant velocity. Is he doing work? Tell me, is he doing some work? Yes. Yes. Good. Explain me how. Suppose I am carrying this biscuit packet like this from here to here. I am only my place. Here the person is also moving. Okay. Suppose I am also moving and carrying this biscuit packet from here to here. So is it work or what? What do you say? Yes. Yes. Yeah, you're right. Okay. So when there's a bucket of water, see like this, it's some bucket. Okay. If I'm carrying this, if I'm applying a force F in this direction, and this bucket is displaced by a good magnitude S, and its new position is now this x2, x1, where x2 minus x1 is S. So I will say that when you apply a force and there is a movement in the direction like this, okay, so I will define work as what? F. In this, I will define this F magnitude S is work here. Yeah, very good. So you know all the things, huh? Is this work? Is this work? A man holding a chair at the arm's length for several minutes, just holding static condition, posed. Is it work? Very good. Yes, you're right. It's not a work. Good. Why? Because let me define the work. So from these three slides, we can say like this: work is what? Work is this. That if suppose there is a block present, this is some block. Okay, Baleris. Okay. Suppose this is some block of mass m, and on the horizontal surface it's kept. If I apply a force F on this, and this block gets displaced by some magnitude S. So remember, work done is defined as displacement of the body, okay, where if I'm applying the force here on this, so point of application of the force must move. Point of application of the force must move along the direction. Then only we can define the work done. If that point of application of the force here is this, it's moving, you can see it's moving. It has moved via some distance. Then we can say it's a work done. Or if you take a simple particle which is having dimensions neglections, okay, we neglect the dimensions, and if I apply a force, it's like laddu, and if I move it with this displacement, I will say force work done is done here. Okay, so we'll define the mathematical equation also. इसमें नहीं है, इसमें it's static, it's not moving, no work done, zero. So what is work then? So it says here, no, these all are not doing any work according to language of science. So you people told yes for this. See, mine case is fine. Mine case is fine. If I take a bucket and if I apply a force like this, I'm doing a work on the bucket. But here they're asking you, a person carries a bucket of water along horizontal path while walking at a constant velocity. Is he doing work? I mean, is not point of application is not moving. No. Okay. If I'm applying a force like this on the bucket, point of application of the force is moving, then the work done is fine. I told yes for you because you people told yes. I explained via this. But according to this, it's wrong. Why? Because you see here, if I am carrying, suppose this is bucket, I am keeping this thing on my hand. Point of application is what? Point of application is palm of my hand points and the base of this, whatever the instrument is, this device. So if I'll keep it here, and if I move my hand, listen students, point of application pe force jo lag raha hai. If I'm moving like this, then I'm doing some work. If I'm carrying just like this, point of application is not moving. So for this thing, we'll say work done defined is zero here. Maybe if I'm holding this, if they ask whatever the force you're applying on this bucket, okay, uska work done, then we can find it. But on with a simple definition, I will say no. Clear ho gaya? So in all the three cases, beginning with which case? Homework case, no work done. Bucket case, if you're just simply carrying and walking, point of application is not moving, so completely will not define. System पे तो zero हो जाएगा ना, bucket पे will say no work done. Third case, कौन सा third case कौन सा है? What is it? This chair holded by a man. It's the work done is zero, no work done. So according to the science students, what is work? You can write this definition. So as I've told, na, it's official thing which I've told. It's not self-made. It's not self-made thing. Okay. So a pillar. This is what, some big rock for the building blocks. If I'm applying a force on this, and it's moving with some d distance here, it's new position. So I will define work done. Okay, and physical significance by the definition is this: work is said to be done when a force is applied on an object and there is a displacement of the point of the application. This is the point of application. It gets displaced up to this. Okay. Direction of the force. In the direction of the force, remember this thing. If the force is this direction, if it's moving, work done is fine. Okay. You'll understand friction bhi karta hai, it's opposite, but for now, just this definition is fine. If the direction is 90 degrees, we say work done will be zero for this. See, students, if this is a building block, if I'm applying force like this, will it move? No. I have to apply like this, then it will move somewhat. And like this, it's moving, see. So I will say, in the direction of the force, when the point of application is moving, we'll say work done is defined. Okay? If you're applying a perpendicular, it's not moving, 90 degree. And if the force and displacement are 90 degree, work done is zero there. You'll see now the mathematical equation. Let me give you that in advance. So we defined work done as a scalar quantity. See, here it's asking work is vector. Okay, let me ask. Vector is scalar or work done is scalar or vector? Sir, आपने बोल ही दिया. Okay, so let us move on. Work done is dot product which you studied of force vector and displacement vector. Somewhere you'll find F dot S vector. So this is F magnitude, S magnitude, cos of the angle between them. If suppose some body is displaced like this, S, and force is acting like this, and angle between the force and displacement is theta. So I will define work done for this is F dot S equals to Fs cos theta. Okay? Yes. No, it's a scalar quantity because see what we have studied. हमने क्या पढ़ा है? That if two vectors are dot producted, the result which we are getting is this, which is scalar multiplied by scalar multiplied by scalar, which is equals to a scalar. That is numerical magnitude algebra. Okay? So we can say here work is a scalar quantity. Dun-dun-dun. Okay, units and dimensions of the work. Let us derive it. Work done is defined as it's a scalar quantity force dot displacement, matlab force magnitude cos theta. Cos theta fluctuates from +1 -1. Again number algebra. Displacement meter. Force is Newton. Newton matlab Newton per meter is the SI unit. So we'll say work done ka SI unit is Newton per meter, and dimensions if you want to see, Newton means force. Force means mass times acceleration into L of displacement. The dimension will come out to be m0 L2 T minus 2. Yes. There is one more combined unit which is written as joules for energy, and work done is nothing but energy only. Okay. So we'll write this unit for this also. We can use this unit. But everywhere you will find in the books Newton per Newton meter, Newton meter, Newton meter. It's not Newton per meter, it's Newton meter. See this, okay? Nature of work. Okay, in this, is the work done positive or negative? Text in this animation, right hand side. Text in the chat box, positive. Right, students, right. So you can see here, see in this, just focus here. In this person is moving this drum. Force is applying on the top and displacement is on the same direction. That is this S vector. Anna? So I will say this. Work done will be force S. Cos of angle between them is force and displacement is in the same direction. Zero parallel. Fs will be the answer. Positive. So here I will say that work done is positive. Okay? Negative work done is this. Because see, negative work done of which? Gravity. So we see this drum again. It is having weight mg down. So work done by R force is positive, that is Fs cos 0 1. But work done by gravity is negative. Why? Because displacement is in the positive direction and force is negative. So I will say for this same case, so it can be this. On a body, many forces are acting. So by one force, the work done can be positive, and by other force, the work done can be negative. So I will say here, work done by gravity mg will be like this. Mg, take the magnitude. Mg vector ka magnitude, displacement vector ka magnitude, mgs, cos of the angle between them. Mg and s are opposite in direction. 180 degree, 180 degree. So I will write here 180 degree. Cos 180 is what? -1. Work done is, but the gravity is minus mgs. Work done is minus mgs. ठीक है, याद रखना. ओके, जीरो वर्क डन क्या होता है स्टूडेंट्स? व्हाट इज जीरो वर्क डन? See, it's a logical thing, very common sense. Okay, if you are applying a force, suppose this is a wall, there are some cabins, but they are fixed in the walls. Okay, so I can't move them. If I'm applying a force on this, I'm applying a force on this. What is happening? I'm not able to move this wall. Fixed. I mean, cabins are fixed. I'm not able to move because they're fixed in the walls. I mean, you can say, okay, I'm applying on the walls. So I'm not able to move the wall now. Why? Because my force is acting like this and displacement is zero. Right? So two cases can be asked for the zero work. Either when you apply the force and displacement is zero. So work done is what basically? No, it's force vector ka magnitude, displacement, cos of the angle between them. Here we are having the displacement only zero. So we'll say net quantity will be zero. Fine. Next, work done zero will be how? In this case, you see this person is, so what is doing? Displacement of the block is in this direction. Mg is acting this direction. So if I say work done by gravity, it will be mg magnitude, displacement magnitude, cos of the angle. Angle is 90 degree. Cos 90 again will be what? Zero. So this is another case of work done zero. ठीक है? Fine? Yes or no? समझ में आ गया? Yes or no? Okay, good. Now let us see a third case. Third case क्या हो सकता है students? Either the force is zero, so it doesn't make sense. Okay, it's simple, funny case. Third case is this. Let us make it, because only two cases exist. Third case is this. So when you say like this, कि force zero है, तो इसका तो कोई मतलब ही नहीं ना. I mean, it doesn't make sense. And the work done is zero. It's a funny case. So take two cases. If you apply the force like this, till the work done is zero. I mean, displacement is zero, work done zero. Or if you, this case, when you keep something on your head and move, so work done by gravity is what? Zero. So this you can consider. Listen, if you draw the LBD of this block, no, two forces are acting on the block. Normal reaction from the head up plus mg on the ground. N is balancing mg. Okay? So work done by mg is zero, n is also zero. Okay? But if it's holding, if you say that some force is acting on it that is keeping it in this direction, so then the work done will be different. Concept test. Are you ready? Ready for the concept test? Solve this question. Tell me the answer. Solve this question. Tell me the answer. Question solve. ठीक है. Okay, so you solved it. Let us solve, okay? So I'm solving this question in front of you now. 15, 60. Displacement 3 meters. It's same. Displacement is equals to distance in this case because positions are not changed in between. Anna? Work done I know is defined as. Okay, stop texting. Your answer is right. F magnitude, displacement magnitude, cos of the angle between them. 3. So angle between the force and a displacement vector is 60 degree. It is how much? Cos 60 is defined as half. So this will give you 22.5 joules as the answer. Okay? All of you got this answer? Very good, excellent. See. Okay, now we are on the work done by the variable force. Are you ready? So we have arrived at the junction point. I mean, the point where either the syllabus will be tested in that point or numericals. I can start from this. But I will start this new topic. And because I hope that in the previous class we ended here. I mean, you have ended here with sir. Anna? Yes? Yes? No? Okay, let us know. What is variable? If someone is asking from you, variable, what is this? What does it mean? It means quantity which changes with respect to any of the other quantity. It means that such quantity is variable quantity. If the quantity is changing with respect to another quantity, suppose you are having your motorbike, Tarzan motorbike, not Tarzan motorbike, it's car kind of, okay, like very big car you're having, rocket car, bullet car, okay, and it's moving like this. Suppose it's a funny animation, okay, and we will say with time the positions are changing, so you will say dx by dt as instantaneous velocity at any time t. So you will say like this, that x is changing with respect to t, so x is variable here. Or if you make a graph like this, so this is a graph. If this is just simple graph, y equals to mx, so you will say with respect to x, y is changing. So y and x basically both are variable here. Okay? So this is the meaning of variable. So with this, you can connect if the distances can be variable. Velocities, if you see the graph of, acceleration. So when the velocity is changing with time, this gives the slope as acceleration. So here the velocities are changing. So if the velocities can be variable, if the positions can be variable, so what the rest things can be variable? I mean, the force can also be variable, no? So force can also change with respect to something. So we define the variable force as such in front of you. You can see here. We'll define the variable force as when the magnitude or direction of the force changes with time or displacement is known as variable force. Let us see. See this. See, this picture, maybe in this picture also, the work is done, by the way. Okay, don't think like this, the work is not done. See this. This block is moved from this position to its ultimate position. This is say x1 position. This was say x2 position. This is say x3 position. This is say x4 position, and this is x5 position. Okay. If you see carefully, x5 minus x1 is equals to complete displacement s. Okay. So I'm writing it here for you. But there is some change here if you focus. See, at x1 point, the force magnitude was F1. At x2 position, the force magnitude is F2. x3 position, force magnitude is F3. x4 position with the force magnitude is F4, x5 with 5. So, I mean, if I write the work done for this, no, I can't write like this now. Force is constant F1 and displacement S. See, displacement is fine, it's constant. But force, I will not write like this now because now the force is a function of x. Okay, or time you can say. So here two things are there. Force is what? It's a function of position and time. Okay, so with time also see, because of course time is always progressive. We'll measure time, we'll on the stopwatch here, and we can end here at tt. So at t0, if this is the picture, at t something, t1, at t22, this will be the picture. At t3 or t4, this will be the picture like this. Let us say t1 and t0 is just static condition. है ना? So force is a function of position and time. I mean, with time t1, the force is fx1. Time t2, the force is fx2. Like this, it's progressing. So for such conditions, we'll say we can't write this formula directly. So now we'll not write this formula. The reason is this. यहाँ तक समझ में आया? Text in the chat box. Are you able to understand this? यहाँ तक up to this thing? A reply here. Why we can't apply this formula? Now this formula is in danger zone. We can't apply. Why? Because force is variable. It's not constant throughout the displacement. So what to do? For such cases, and these are also some variable forces graphs. I mean, if the force is a function of time, see, I told no. Function of, see, force can be both. Function can be like this, 2t plus x square. So this you will call at force is what? Function of x and t. It can be separate also. Force is just a function of position like this. It can be like this. Force is just a function of time like this. This is the graphs corresponding. This is parabola. This is slope, mx. X is what? T here. Y is what? Force here. ठीक है? Spring force पे बात करते हैं थोड़ा. We have seen now variable force. We'll find the work done afterwards. Hold on. Spring force. If you see the spring force is what? Spring force is directly proportional to the, from the mean position. It's opposite to the displacement. I mean, है ना? This slide. ठीक है. Okay, now moving the next. Okay, Billy. See, all of you know the spring force is like this. So when this is a natural position, natural length. If I am extending the spring, force will be in opposite direction to the displacement. If I'm compressing the spring, force will be again opposite direction to the displacement, either compression or, okay. So we can write, to make it a equation, constant. This is known as Hooke's constant. Spring constant. Somewhere you find Hooke's. This law is known as Hooke's law. K is proportional to the stiffness of the strings. Stiffness means, I mean, if it's very stiff, it's difficult to compress or extend it. If it's loose, it's very easy to compress or extend. You can see this here. The spring force is also a function of x. But how? It is negative of x. And with constant. So this is also variable force. So now also we get, it's not just random. If someone asks from us, tell me an example of a variable force. Now you can say them, spring force is an example of variable force. So for all these forces, which are either function of both x and t, function of just x square, or I mean x, function of just time. So for all this variable force, you know, or you could say the spring force, because it is also a function of x here. So for all these forces are known as what? This come under the category of variable force. So ab iske liye, for these forces, how to find the work done? This is our question now. So this is in the next slide. Work done by variable force. Okay, because we have seen one example, no? Positions were there, with the time it's changing, the forces were changing, you know? So for such case, you use this formula. No need to go into the depths, okay? There's some graphs there. Time nahi abhi, I can't explain this. But for now, remember this thing. You have to break. So you have to use the integration method here. You have to break the segments, okay? So I will say like this. See this. Suppose this was the initial position, say x1. This is the final position, say x5. है ना? And the time starts at t1 point t1 time पे x1 position, t2 time पे x2 position, t3 time पे x3 position, t4 time पे x4 position, t5 time पे x5 position. Okay. since you know that read the graph. If you read the graph properly here, see this. This is a static condition T0. I mean, the particle was just, it was, it was being acted by the force. So this force is, suppose I'm starting with T1. Leave T0. T0 is a static condition. No force, no displacement. So at T1 time, the position it is attained x1 with the force this, say F1. At T2 time, the position attained is this. Force is F2. T3 time, position attained is x3. Force is F3. Okay? So all these are the pictures here. Now, if you need to find the work done, I will say, see, if you see the simple work done, it is defined as F into displacement. So small work done for small displacements will be this. So I will take a dx element here and I will integrate within the limits xi to xf by taking a dx. This is a dx length element. Okay? So it will be like this. Now see it carefully. This will be like this. Okay. So the delta x is nothing but its delta tends to 0 kind of small. It's dx. So you'll integrate this within the limits this to this. You get the net answer like this. So this is area under curve. Basically, area under which curve? Force and displacement will give you the work done. So this is how you'll find. Also for the spring force, if I apply, see, put here force minus kx. Integrate it. You'll get what? This is equals to minus kx square by 2. Okay, from 0 to x particularly. If I show you, it's a time we are not having the time. See this. Answer is what? This much. Okay. So students, the time is up. There are many things to be done, by the way, but okay, no problem, because we have not completed this. No. So sir will start again, but remember this formula. Okay. How we have used it. General formula is this for variable forces work done. Okay. So students, I'm ending the class. Bye bye everyone. We'll meet in the next class. Got it? All of you? I hope it's clear. So we'll meet in the next class. Till then, bye bye everyone. Just hold on. Okay, students. Bye everyone. Okay. I hope you're able to see the slide. So for reference, you can use the material of HCB. For reference, use HCB material. Okay, bye. Bye everyone. Okay, bye bye. I'm going to stop the stream. Okay.